Okay, so this is a question which is named as subset sum equal to k. So first of all, what is in this question there? We are given an array which is a nums array, and there's another target k value there. And what our task is here? So the task is to determine whether there exists a subset of the array whose sum is equal to k. So that is our question there. Like we have to find is if there are any kind of the subset possible here whose sum is equal to the target value k there. So now this is the constraint there. We have to go for these test cases there. So this is array 1 there, this is array 2 there, and like now we have to check for this don't confuse with the type of the like how is the input is given there. So don't concern about this 4 5 and 2, what is this 2, what is this 4 5. This is nothing but the first of all this is for the t means test cases. So this is for the test case 1, this is for test case 2 there, and this 4 is nothing but the array of the size of the array, and this 5 is nothing but the value of k. So like let's say if in this array we have to find if there any kind of the subset possible here. So yeah, so if we have to choose this 3 and 2, so like this is our array 4 3 2 1 there, and k is equal to 5. So yeah, there exist some subsets with sum is equal to k. So what are those subsets there? So these are either 4 1 there. So this is the valid answer, and 3 2 is also valid. And I think you know very well like subset, what do you mean subset? Subset doesn't need to be continuous in nature, but the order remains same there. So like in case if you have to find any of the, so we simply return true there. Similarly for the input 2 there are the many of the test cases given there. So like come to the question part. So let's say what's the key idea behind this. So we can say at every element we have two choices: either we have to take that element in our subset there, or either we have to skip that element. So let's say we have to, if we take the element there, so the our remaining target it is reduces there, and if we skip it the target remains the same. So like we can say at every position we have the two possibilities there. So now we have to judge whether what we should go to forward after it. So in cases when we have two multiple choices there, so we should go for the recursive solution there. So that's why we should go for the recursion there. And like now we can say if at any point that our target remaining target becomes 0, so that is our valid subset, and now and then we have to return simply true there. Okay, so now come to the dry run part there. Let's say first of all I have to write what's the since I used recursion there, so that's my the I have to call f of index comma target there. So that is my recursion. And what it means, it simply means like it suggests me can we form the target using the elements from index to end of the array. like what it means there, can we form target sum from index to end of array. So this is nothing but this is the meaning of this our function. This is the definition of our function there. So like I have to talk about this test case number where I have to use this array nums 1 2 3 there, and like we have to seek is there any of the subset whose sum is equal to 4 there. So what it means, we usually find 0 4 there. So what it means, this is nothing but we have to start from the 0 index there to end there, and this is our current or remaining sum there, and we have to reach till in any of the state if our remaining sum becomes 0. So that is our desired target, or that is our desired subset there. So we simply return in case true there. Okay, so like what it means, so it means so can we form sum is equal to 4 using the elements that is starting from index number 0. So what it means, simply the we have to start from the starting of the array, and let's say we have to call for the okay, after it I have to simply draw the recursive tree there. To explain you one thing that we have to wait a second there. Okay, one thing we can say, there are the two cases only. Either we have to take the element, or either we have to skip that element. We can say other we have to take and escape. And we can say what in the case of the take, so like we are not able to take in in every cases. Firstly we can say we have to take the element at index I, so our target decreases by that's index element there. What it mean, so this is nothing but the let's say if I take that element, so I have to call simply its next part there, and here our target value decreases by the nums, or let's say yeah, I can call it as nums of index. Okay, so that is our, if I have to take that, I have to call simply the our succeeding index there. And like there's only, this is only allowed, I can say this is allowed only in the case, only if our nums of target uh, wait a second there. Okay, I write there. Okay, so I say one thing there. So in which case we have to simply take that position, so we take only in the case whenever this our is equal to target value. So only this is the only condition when we are able to take that. And like similarly for the condition of skipping, so if we have to skip that element, we simply call for our next function. So for it I have to simply call the index number, and the target remains same there. So these are the two cases in which we have to call for each of the element when we are standing at any index I there. Okay, so and now afterward we can say, so we simply move to the f of index plus 1 target, index f of index plus 1 comma what are the remaining target remain there. So we can say one thing there, that our f of index comma target is either take or escape. Why we use the or operation here? Because this is simply boolean, true or false. So whether in any of the cases it is remaining true, so that is our resultant true there. Okay, so we can say one thing there, that our index comma target is nothing but the, so it is nothing but the simply that take conditions of this this whole part, and similarly we have to do this or operation with our skip part there. So not need to read add this again and again there. Okay, so now like to explain it more, I have to draw the recursive tree here. So first of all we have to start with the f of 0 comma 4, that after it has to end to the till end there. So how the recursion goes on, so this is f comma 0 comma 4 there. Okay, so this is f of 0 comma 4. So how is it calls? So there are the two cases there, either we have to, wait a second, why is it take that part here? I think this is selected in this complete part there. So let's say we have to go to this upper part here. Okay, I think we should write from there. So this is if we have to start from the f of 0 comma 4. So what are the possible cases for it? So one case for this, one case for this. So this is the take side, this is for the skip side. So what if we have to take that part, so we go for the other index, and what's our remaining target become? It become 3, because at initial our index number, our nums is simply the 1 comma 2 comma 3. Okay, and if we have to skip that part, we simply it become 1 comma 4. Okay, so similarly like this goes on, and there's no need to elaborate this again and again. Let's have to explain you. I have to draw this till we have to recover, or till we have to find any of the repeating cases, so that there's need, why there's need to for the DP there. Okay, so this is called for the f of 2, and similarly this is called for the f of 3 there. This is 4 comma f of 2 there, and this is for 2 comma 4 there. And we can say one thing there, like if you have to reach to 2 comma 1, and since the last element is 3, so we are not able to take it. So there's only condition possible is we have to skip that part. So there's only one way possible. But for this here it is there's a two condition possible here. Again here only one possible here two possible here. Okay, so like after it I have to simply write this. So f of 2 comma 1, we simply skip that part, so that become f of 3 comma 1. In case you have to take this become 3 comma 0 there, and this becomes 3 comma 3 there. And like let's have to write this part here, f of 3 comma 2 here. Actually this is for, I have to simply extend this part to here. Okay, and we have to write this at here, f of 3 comma 1 here, and similarly f of 3 comma 4. So like no need to make it you can understand. We see one thing there, that this is repeating again. Similarly there are the many of the cases when we take the bigger test case here, we see many of the states that are repeating again and again. So what it means, firstly we see one thing there, there's f of 3 comma 0. So what it means, we reach to f of 3 means we are to out of the array, but our target becomes 0. So what it means, we are able to find the that valid set. So that means we have to return true because we are able to find that. So what it means, f of 3 comma 0. So first of all we have to take that part, now we have to skip and that take. So what it means, we have to take that, skip that, take. So mean 1 plus 3 become 4. So that is our subset, or our valid subset in this nums is 1 comma 3. So but there's no need to return that subarray, we have to simply return true false there. So simply since there are the to avoid that recomputation for each of the state, we simply store that. So how we store, we simply use the dp vector for storing. So since what are the variables that are vary here, so we simply vary index here, and there's a target value, so that's why we have to call for the 2d dp. And what are the parameters that are the varying in the dp, that we are need to call for the dp here. So there's a need for the index there, and there's a target there. So since the constraint index is goes to till the size, so that's why we to take the n. And what's the value of the target, it is k. So for the safe case we take the k plus 1, because to handle the 0 and last case there also. Okay, so this is for the first of all, like you can see there's the recursion the brute force code there. This is simply the, we have to call, this is the main function, we have to call this is the end of the k and this array. There's are the base cases, if we are able to reach the target is equal to 0, we simply return the true. We are not need necessary to call for the another of the subtree there, we simply stop at there. And in the cases if I is equal to 0, since we have to start from the end, and like we have to able we are reaching to I is equal to 0, mean we are reaching at the ending of the our array. So we can see whether it is equal to our target or not. So if it is not the target, so means we are not able to take that part, and after it we goes to beyond the array, so there's no need to go to here. So we simply return true or false at this step by judging what its element value is equal to target or not. Okay, and these are the two cases, there's a not take and take. Now since for the take case, we have to checking whether we are able to take or not. So that's why I simply initialize it with false, and now check with this condition, if this value is less than equal to target, that's why that's only the possible condition that we have to take that part. Simply I minus 1 the comma target, the I minus 1 comma target, since the target value also decreases here. And like what's the time complexity for this is nothing but the, since this is a brute force, so every element has a two options there, so that's why the exponential time complexity become 2 power n there. And what's the space complexity here, it is nothing but the of n there, that is of recursion stack space. Okay. So since this constraint is very high, so exponential time complexity is, it doesn't gives accepted, it gives the TLE. So that's why we should go for the DP version, that is our memoirs. So there's nothing, we simply use our DP extra vector there, and we pass this in our solve function. We write this our, so that if we have two able, we are finding any value that are found in early stages, we simply use that value and simply pass this on our DP and return it. So this is memoization version. And what its time complexity is, nothing but the, first of all, there's a of n comma n into k. This is the time complexity is n into k there. And what the space complexity, again n into k the for the DP table, and since for recursion stack also of n, so that is for the DP. So there, so this is our memoirs code and it is acceptable there.